Hey, welcome back. Mr. Richardson here, and we're doing lesson 1.3 today. We're going to take a look at phospholipids. So here we go. And this is 1.3. We're looking at, as you just said, phospholipids. So these are actually going to be really similar to triglycerides. You'll be able to see, you should be able to see why these two, phospholipids and triglycerides, would both fall into the same class of macromolecule, that being the lipid class of macromolecule. So phospholipids are structurally very similar to triglycerides, except in place of that third fatty acid that a triglyceride had, again, think tri, meaning three. There you go. Tri meaning three. So three fatty acid tails. In place of that third fatty acid, they're going to have what we call a phosphate head. Got head in parentheses there, it's kind of a nickname, the head. So let's take a look at what a phospholipid looks like. So here are two fatty acid tails. And they're connected to, hopefully we're starting to recognize this structure here, the three carbons with the O's on them. This is a glycerol. So far, our diagram looks pretty much identical to what a triglyceride would look like. If this could be a triglyceride. If we just add another fatty acid tail right here, we would have ourselves a triglyceride. But that's where the difference comes in. We are not going to add another fatty acid tail. Instead, we're going to add what's called a phosphate group. And this is a phosphate group. So the whole thing now is a phospholipid. It's made up of three parts. It's got two fatty acid tails, a glycerol, and a phosphate group head up here on top. Now, this charge is actually really important. So it's not a mistaken line I've drawn. It's not another bond. It's a negative charge. And that is really important for our phospholipids. Went off the camera there. So due to that negative charge that the phosphate group has, it's what we call hydrophilic. It loves water. So philic means water. Philic means love. Hydro means water. So it loves water, loves to be near water. And that hopefully kind of makes sense. Going back to lesson 1.1, we talked about water having the positive and negative charges. So like a magnet, It's attracted to other positive and negative charges, like the negative phosphate. What it's not attracted to are these tails up here. There's no positive, no negative on these tails. Water does not interact with fatty acids, but it does want to interact with the phosphate group. So that leads to some very important characteristics. And honestly, we kind of owe life too. So this creates what we call an amphipathic molecule. So I've got some good news for you. From now on, we're not going to have to draw the C's and the H's and all the bonds and everything. From now on, we can just draw a phospholipid like this, like a lollipop with two stems on it. Here's the head, the two tails right here. So from now on, we're allowed to draw phospholipids that just look like that. Again, the important part here is that that head is hydrophilic. That head loves water. Once it's near water, it's going to do whatever it can to interact with water. The tails are completely opposite. They're going to do everything they can to stay dry. They're hydrophobic. Completely misspelled that word. Good thing I stopped to explain some things here. Hydrophobic, I apologize for that. So the tails are hydrophobic. They're trying to stay dry as much as possible, trying to avoid the water. And that's going to be what creates our cell membrane. So due to that amphipathic nature, that half of it loves water, half of it hates water, when groups of phospholipids are in water, they're going to clump together. They're going to naturally form these clumps together, and they're going to arrange themselves so that the heads face outwards towards the water, and the tails all point in the middle and stay dry. And we call this structure a micelle. So here we have all those phospholipids. They're all putting their tails in the middle where it's dry. There is no water. There's water all around the outside here. So all of this is water. The heads get to interact with the water. The tails stay dry. And again, this structure here is called a micelle. Just a natural formation due to the fact that the heads want to interact with the water and the tails want to stay on the inside where it's dry. So very, very important structure here, the phospholipid bilayer. As our micelle grows, as we continue to add more and more and more phospholipids, they actually end up forming a double layer of phospholipids. We call that the phospholipid bilayer, and end up with aqueous solutions both in the interior and on the exterior. So diagram that. There we go. There's our outer layer. And there's our inner layer. Since we've got two layers here, and these are phospholipids, so they each have two tails. So here is our bilayer, our double layer here. So you can see, again, it's got two layers. It's got heads on the top and heads on the bottom, and all the tails kick into the middle. This allows it to be water on the inside and water on the outside, and all the way through the middle here just stays dry. It opens up a barrier. We can keep things in the middle from interacting with things on the outside because of this barrier. We've got things dissolved in the middle, or things floating around in the middle, things floating around the outside, and we can keep them separated because they just can't cross that barrier. The water and water-soluble substances are not going to interact with these insoluble fatty acid tails. And this is the beginnings, the makings of a cell. We are starting to form a cell here. It had to be a lot larger. This is way too small, and I'm not going to draw anything any bigger. It's a lot of circles, a lot of lines. But if this were to get larger and larger and larger and larger, you could put more and more things in the middle here, like a nucleus, mitochondria, other things that cells have, and you're starting to form a cell. So that phospholipid bilayer at the bottom of the page. That phospholipid bilayer is the foundation of all cell membranes. I don't know a cell on Earth that doesn't have a phospholipid bilayer as its cell membrane. Quite certainly all do. And since we have not yet found life not on Earth, I think we can say all life has this phospholipid bilayer. And it's all due to that incredible water and the interactions water has, where it is attracted to negative charges of the heads, but is repelled by those tails in the middle there they won't interact with water. So every cell that we know is all just based on that phospholipid bilayer and those very simple chemical reactions and interactions, excuse me. So really cool stuff. We've got the basis of why a cell forms in the first place right there. So that finishes 1.3. So I'll see you guys again next time we get to 1.4. We'll talk about some of the basic cells like bacteria. Till then, have a great weekend.